inside here. So inside this steel box is basically a tube. It's a stainless steel tube, and on the inside of the tube is a mesh, almost like imagine you take the mesh from your screen door and roll it up. It's a special mesh made of molybdenum, which is on the inside of this pipe. And when we start out at room temperature, we put some lithium in there, and lithium's a metal. It's a soft metal. We put it inside, and then we heat this pipe up to about 1,000 degrees centigrade. And when you heat it up to 1,000 degrees centigrade, what happens is the lithium melts, and it clings to that mesh like the wick of a candle. So now I have a pipe that has liquid molten lithium on the outside, and then lithium vapor on the inside. And when the beam comes into that vapor, if for all those lithium molecules we take the electrons off, we now have a positively charged lithium nucleus and a free electron floating around. That gas of those positively charged lithium atoms and the electrons floating around is called a plasma. And when you separate the charges in there, when you first start, for every atom there's an electron nearby. The electric field is kind of zero. It's electrically neutral. But when the beam comes in, you can cause the electrons to come to one side and the ions to go to another, and you get a big separation of charge, which makes a very big electric field. So we don't do that in a static way. When the beam comes in, it makes a wave which propagates through here at the